Hello, first graders, it's Mrs. Belatesh, and we're going to get started on our engineering project for our next unit. So remember, last week I read the story to you, Paolo's parachute mission. And Paolo wanted to, he and his friend wanted to drop some fruit from a tree high up in the air, and they wanted the fruit to land on the ground without cracking. So they came up with the idea of using a parachute, and they tested some different ways to make the parachute fall as slowly as they could, right? And they discovered that there are three parts of the parachute. There is the canopy, which is going to be capturing the air. It will increase the air resistance. There are the lines or the strings of the canopy, of the parachute. And then there's the load. So Paolo, they knew what the load was. They knew the weight of those fruits, and they wanted them to land on the ground without cracking open. So our job is that we are going to pretend that we are aerospace engineers, and we're going to land a rover on Mars. So we need to know a little bit about Mars. We know that Mars is a slightly smaller planet than Earth, and we also know that Mars has a thinner atmosphere. It does have an atmosphere, but it is thinner than Earth's atmosphere. Hey, I want to remind us, what does the word atmosphere mean? What is an atmosphere? Well, the atmosphere is this layer of air and gases that surround the Earth that allow us to breathe. The atmosphere protects the Earth, and it slows down parachutes when you want to land something on the Earth. So we need to design something that will drop a rover, like a robot, on Mars. Tony Boney here thought he would help me out. Are you ready, Tony? Okay, first graders, so Tony Boney and I are thinking about how we can design a parachute that will lower a robot or a rover as slowly as possible onto the surface of Mars. So, with an engineer, what you try to do is you ask some questions like, how can we slow down the parachute? And then you imagine some solutions and you make a design. But I think that we need to gather some information before we can actually make our design. So what we're going to do is that we're going to go out and we're going to test 3 different variables, things that we can change. So let's just look at a parachute. A parachute has a canopy. That's the big space that's going to capture the air. It has these lines or strings, and it has the load. So the load is going to be the same. We're going to know what the load is going to be. But we can change the size of the canopy, and we can change the type of material of the canopy, and we can change how long the string is. So this is what I want us to test when we go outside to try this experiment, okay? So number 1, I want to test the size of the canopy. If we have a really big canopy, will it catch more air and fall down slower? If we have a medium canopy, how fast will it fall? And how fast will a small canopy fall? So I want us to investigate the size of the canopy. The next thing I want to investigate is the length of the string. If the string is really long, maybe it opens the canopy up all the way and it falls slower. If the string is really short, maybe that'll be good. I don't know. So I want to test the length of the string, long, medium, and short. And finally, I want to test the type of material that the canopy is made out of. So I'm going to test 4 different things. I'm going to test paper. I'm going to use a coffee filter and see if the coffee filter falls very slowly. I'm going to test a plastic bag because plastic won't let the air go through. And I'm going to test some cloth. And I'm going to test 2 types of cloth, a thick piece of cloth and a thin piece of cloth. Now I'm gonna go out and I'm gonna test these things by dropping these parachutes from the top of the stairs. Now, if you want, you can test these things yourself, or you can just watch my tests and get some ideas, okay? All right, I'm excited about it. Let's go try. Hello, Cougars. So this is Mrs. Belatash, and I'm outside. And remember when we were talking about the parachutes, when we looked at the canopy, we wanted to talk about 3 different sizes of the canopy. So I have some parachutes that I made, and these parachutes have 3 different sizes. I have a small canopy, a medium-sized canopy, and a large canopy. They all have the same length of string, and they all have the same load. So we need to make sure that those other things are the same. We're just testing the size of the canopy. Okay, so boys and girls, this is the large parachute. 1001, 1002, 1003, 1004, 1005, 1006. 6 seconds. Okay, so boys and girls, this is the medium parachute. 1001, 1002, 1003, 1004. Okay, boys and girls, now it is the small parachute. 1001, 1002, 1003. 3 seconds. So, boys and girls, we just looked at the size of the canopy. And I remember seeing that the large canopy went down the slowest. It was 6 seconds. It took 6 seconds for the large canopy to float down to the ground. So that's the first thing that we're gonna test. Now we're gonna test the length of the line. Let's get started. Okay, so boys and girls, this is the long string. We're gonna see how long it takes for the long string to fall. Ready, and 1001, 1002, 1003. All right, so boys and girls, now we have the medium string. We're gonna see how fast the medium string goes down. And drop. 1001, 1002, 1003, 1004. Okay, and now we have the short string. And 1001, 1002, 1003, 1004. So that was interesting, the length of the string. My prediction was that the long string would be the slowest, but that's not what happened. The long string, I think, took 3 seconds, but the medium and the short string both took 4 seconds. This is one of the things I love about science. Sometimes I'm surprised by the results of my experiments. Okay, we have one more test to go. So, boys and girls, we tested the size of the canopy. We've tested the length of the string. The last thing that we're gonna test is the type of material that the canopy is made out of. We're gonna test coffee filters, plastic bag, and a cloth. Okay, so this is a coffee filter, medium size, with a medium length of string. Let's go. 1001, 1002, 1003, 1004. 4.5 seconds, almost 5 seconds. Okay, boys and girls, this is a plastic bag. So this is a plastic canopy with a medium size. Ready, drop. 1001, 1002, 1003, 1004. Whoops, and it landed in the bushes. So boys and girls, I actually have 2 types of cloth. I have a thicker cloth, and in a minute we're going to try a thinner cloth. So this is a cloth, a heavy cloth, along with that's a medium size and medium string. 1001, 1002, 1003. 3 seconds. So this is the second type of cloth. This is a very thin cloth, but it's a medium length, a medium size, and medium strings. Ready? 1001, 1002, 1003. Beautiful. Okay, boys and girls, so we just came back in from doing all those tests, and I want us to kind of look at the results. So when we looked at the size of the canopy, the largest size went the slowest. So definitely the largest one caught more air. When we looked at the strength of the line, I was surprised because I thought a long string would be best, but it looks like the medium and the short were better, okay? Then we looked at the type of material. Now we had a little problem because the coffee filter took 4.5 seconds. The plastic took 4 seconds but landed on a bush. So I would say that they're both equal. Both the coffee filter and the plastic were the same amount of time. The cloth, the thick cloth, was faster, 3 seconds. The thin cloth was 3 seconds. The only thing I would say about the thin cloth is it did really land smoothly. So now what we need to come up with is an idea. What are some of the, using this information, how would you design a parachute that would land as slowly as possible on Mars? So, this is their data. I want you to make a plan. Choose the materials. What size of canopy, what length of string, and what type of material that you're going to use. And then next week, we're going to build it. All right? Sounds great, Cougars.